For what value of k will the linear system be consistent? Remember, a system is consistent if it has one solution or infinite solutions. Looking at the system below, notice k is the constant in equation 2. Because we have three equations with two unknowns, if we write the augmented matrix in reduced row echelon form, we must have a row of zeros in row 3 in order for the system to be consistent. So let's begin with the augmented matrix for the given system, and then write the augmented matrix in reduced row echelon form. Notice equation 1 gives us the row 1, 3, 4. Equation 2 gives us the row 9, 1k. Equation 3 gives us the row negative 3, 7, 2. Let's begin by obtaining a 0 in row 2, column 1, as well as row 3, column 1. Looking at row 2 and row 3, notice 3 times negative 3 plus 9 is 0, and therefore we will replace row 2 with 3 times row 3 plus row 2. And now looking at row 1 and row 3, notice 3 times 1 plus negative 3 is 0. Let's also replace row 3 with 3 times row 1 plus row 3. So we keep row 1 the same for now. And now replacing row 2 with 3 times row 3 plus row 2, we begin with 3 times negative 3, which is negative 9, plus 9, which is 0. Next we have 3 times 7, which is 21, plus 1, which is 22. And then we have 3 times 2, which is 6, plus k, giving us 6 plus k. And now we replace row 3 with 3 times row 1 plus row 3. 3 times 1 plus negative 3 is 0. 3 times 3 is 9, plus 7 is 16. And 3 times 4 is 12, plus 2 is 14. For the next step, let's make the entry in row 2, column 2, a 1 by replacing row 2 with 1/22 times row 2. Row 1 and row 3 remain the same. Multiplying row 2 by 1/22, we have 0, 1, and then 1/22 times the quantity 6 plus k is the quantity 6 plus k divided by 22. And now let's obtain a 0 in row 3, column 2. Looking at row 2 and row 3, notice negative 16 times 1 plus 16 is 0. Let's replace row 3 with negative 16 times row 2 plus row 3. We will keep row 1 and row 2 the same. Replacing row 3 with negative 16 times row 2 plus row 3, we have negative 16 times 0 plus 0, which is 0. Negative 16 times 1 plus 16 is 0. And then we have negative 16 times the quantity 6 plus k divided by 22 plus 14. Let's work this out below. The element in row 3, column 3 is equal to, again we have negative 16, or negative 16 over 1, times the quantity 6 plus k over 22, and then plus 14, or plus 14 over 1. Notice we can simplify before multiplying here. Negative 16 and 22 share a common factor of 2. 22 simplifies to 11. Negative 16 simplifies to negative 8. Notice now we have a denominator of 11. To write 14 as a fraction with the denominator of 11, we multiply the numerator and denominator by 11. So the entire expression is going to be over 11. In the numerator, we distribute negative 8. Negative 8 times 6 is negative 48. And then we have negative 8 times k, giving us minus 8k. And then plus 14 times 11 is equal to 154. So simplifying one more time in the numerator, negative 48 plus 154 is equal to 106. The numerator is negative 8k plus 106. And now we almost have reduced row echelon form. We just need a 0 in row 1, column 2. Looking at row 1 and row 2, notice negative 3 times 1 plus 3 is 0. We will now replace row 1 with negative 3 times row 2 plus row 1. To begin, we have negative 3 times 0 plus 1, which is 1. And then we have negative 3 times 1 plus 3, which is 0. And then we have negative 3 times the quantity 6 plus k over 22 plus 4. Again, let's work this out below. The element in row 1, column 3 is equal to, again, negative 3, or negative 3 over 1, times the quantity 6 plus k over 22, and then plus 4 over 1. For this first product, nothing simplifies, so the common denominator is going to be 22. Let's write 4 over 1 as an equivalent fraction with the denominator of 22. So we have a common denominator of 22 now. And the numerator is going to be, distributing negative 3, we have negative 18 minus 3k, and then plus 88. Simplifying, negative 18 plus 88 is 70. We have negative 3k plus 70 all over 22. And row 2 and row 3 remain the same. Notice now we do have the augmented matrix in reduced row echelon form. And again, from here, because we have 3 equations with 2 unknowns, in order for the system to be consistent, the third row must all be zeros, and therefore to find the value of k, we set the quantity negative 8k plus 106 all divided by 11 equal to 0 and solve for k. If the fraction equals 0, we should recognize the numerator has to be 0, but if we don't, we can clear the fraction by multiplying both sides by 11. But again, notice how on the right side we still have 0. So we have negative 8k plus 106 equals 0. Subtracting 106 on both sides, we have negative 8k equals negative 106. Dividing both sides by negative 8. Simplifying, we have k is equal to positive 106 divided by 8. But this does simplify. Both have a common factor of 2, giving us 53/4. So now we know, in order for the system to be consistent, k must equal 53/4. Let's take a look at what this actually means. So we just found the value of k, so we know the second equation must be 9x sub 1 plus x sub 2 equals 53/4. If we replace x sub 1 with x and x sub 2 with y, we can graph the linear equations on the coordinate plane, which I've done here on the right. Notice how we have all 3 equations and all 3 lines intersect in one point, which is the solution to the system, verifying the system is consistent. Without the graph, if we go back to the augmented matrix in reduced row echelon form, which is this matrix here, we know x sub 1 is equal to the quantity negative 3k plus 70 all over 22, and x sub 2 is equal to 6 plus k divided by 22. To find the values of x and y by hand, we would now substitute 53/4 for k in order to find x sub 1 and x sub 2, which I've shown below. Notice how the solutions do match what we found graphically on the right. I hope you found this helpful.